Do you sometimes think about time travel? Yeah, me neither. But every now and then there's an article or a documentary that will get us all excited for a good few minutes by claiming we have found a way to build a time machine. In these cases, however, it turns out to be some clever maths, a thought experiment, or just plain wrong. This is the issue that if you travel back in time and kill your grandfather before your father was born, you would never have been born yourself and thus could not have traveled back in time to kill your grandfather in the first place. How can that be? We lines also look at a recent paper which claims to have solved this paradox and figure out whether time travel might really be possible after all. If you enjoy optimistic science and text stories, consider subscribing. Let's start with a summary of the grandfather paradox. Time travel into the past seems to be impossible because it creates logical issues. The most famous one is the grandfather paradox. Imagine you travel back in time and kill your grandfather before he meets your grandmother. You wouldn't have been born since your father wouldn't have been born either. So, how could you have traveled back in time in the first place? There are many proposed solutions to this paradox, like the Novikov self-consistency principle. That basically says you cannot perform an action in the past that would prevent you from doing that very same action in the first place. A more exotic solution is that the universe splits into different timelines when you do something that creates a paradox. That sounds correct to me, even though I don't know how such splitting would work exactly. However, there's a new idea in town. It comes from a paper by physicists at the University of Göttingen in Germany and the Perimeter Institute for Theoretical Physics in Canada. They say paradoxes are only apparent and actually there's only one consistent timeline. Let me explain. They start with a thought experiment. Imagine an ant moving around on a piece of paper. The ant travels from A to B and back again. For the ant, the trip from A to B and back is one and the same path. There's no branching. But if you draw the path of the ant on the paper, it looks like this. This is a closed loop. The physicists now ask what happens if the ant moves on a surface that is not flat but has wormholes and cosmic strings. Wormholes are hypothetical tunnels through spacetime. Cosmic strings are one-dimensional defects in spacetime that are left over from the early hot phase of the universe. These two objects are very much real. We have plenty of evidence for wormholes. I joke, but we have no direct evidence for them, only indirect evidence that they may exist. But we also have no evidence that cosmic strings exist. However, their existence is mathematically possible, and some physicists believe they are likely to exist. So back to the ant. On a flat surface, the ant can go from A to B only once. But on a surface with wormholes and cosmic strings, the ant can encounter itself going from A to B again. And if it runs into itself, it could theoretically reverse its direction and continue on its path. In other words, the ant could travel back in time. And if that works for ants, why shouldn't it work for humans? Here's where things get tricky. If our ant falls into a wormhole at point B and comes out at A, it seems as if it has traveled back in time. But in reality, the ant's entire path is still just a closed loop. The ant does not move forward and backward. It always moves in one direction along the same path. It's just that we call the parts of the path with wormholes time travel. If that's the case, the ant doesn't run into itself, but into a copy of itself that came from the future. So if that's the case, why is the ant able to reverse its direction at point B? Because the ant meets a copy of itself coming from the future, which is identical except that it runs in the opposite direction. So the ants exchange information and coordinates so that one of them goes back while the other continues to go forward. Okay, cool, but what does this tell us about time travel? The authors claim that their model shows that the universe can be consistent without having multiple timelines or alternate universes. Even if you go back in time and kill your grandfather, everything remains consistent. You just need to make sure that you meet a copy of yourself coming from the future. But this copy of you must also come back and kill this copy of your grandfather. Otherwise, you wouldn't exist to go back in time in the first place. So it appears that the universe ensures consistency by creating copies of you who do the opposite. You go back in time and kill your grandfather, and a copy of you comes back in time to ensure that this copy of you can kill your grandfather. This means that they can't interact with each other. So you can't meet the copy of yourself and certainly can't talk to it. It arises because we assume that all time travelers moving back in time do the exact same thing. However, if they were to do the opposite, everything would work out fine. The authors say that their model of the universe can be applied to any type of system that can travel back in time, not just time machines. For example, it could be used to describe systems that simulate time travel. The authors also point out that this model is consistent with quantum mechanics. However, at the moment, the idea is still in the realm of theoretical physics. To demonstrate that it could work in reality would require finding wormholes and cosmic strings, which we have not done yet. And it would also require experimental confirmation that time travel is possible, so it's still a bit of a way off. In any case, this is an interesting new approach to solving the issue of time travel. It's similar to the many worlds interpretation of quantum mechanics, which says that the universe splits into different timelines whenever a quantum event occurs. But here the timelines split only when you go back in time and change something. What do you think of this new approach to time travel? Let me know in the comments. By the way, if you prefer reading over watching videos, you can find a written version of our science news on a website. Thanks for watching. See you tomorrow.